right, let's see how this works for us. If our truth table here is a truth functional definition of our connective, right? We define what the connective means by how the inputs generate this outcome. How do we use that in our reasoning? All right, here's a couple examples here. This is going to be a good inference, and this is going to be a bad inference. So here we have a premise that says, if P, then Q. All right, let's just keep going. And our second premise says that the antecedent of that conditional as well, right? It posits the antecedent of that conditional. Posits, that's an important word here. Okay, so what we do when we make our inferences, what we do when we test for validity, is we assume or assign truth to our premises. Now notice here, our second premise just says P. Is P true? What does that even mean? P is a variable here that you can replace with any sentence with truth or false, truth or falsity, right? Any sentence, any declarative sentence is P. So P is true, but P is false. P is everything here. So when we want to think about the inference from our premises to our conclusion, what we really need to do is think, well, if our premises were true, subjunctive counter to fact, right? If our premises were true, or if our premises are true, what do we get out of that? So the natural thing here, the natural conclusion to draw, well, look, if I go to the store, then I'll bring you a drink, and I went to the store, I must have, if that's true and that's true, I must have brought you a drink. All right, so how does this work? Well, let's look at our truth table and let's see what happens, right? Think of these lines of the truth table as different models of what the world could be like, right? So what happens in a world where we have a true conditional and the antecedent is true? What happens if we try to model on our truth table here both of these premises being true? All right, well, true conditional happens here, here, and here. True conditional and true antecedent only happens here. So the only way to have P be true and the conditional be true, because here the conditional is false. It's the only way to have the conditional be true and P true. So the only model that would make these premises both true doesn't tell us anything about Q as a conclusion. Yeah, it sure does. The only way to make P true and if P then Q true is if Q is true too. So this is a valid inference. It's not possible to have true premises without also making the conclusion true. If the premises are true, it's guaranteed that the conclusion is true too. That's what validity looks like, right? We don't know if these are true, right? Hey, these are variables. These are true and false. These are everything, right? But any statements that you plug in that have these premises, these two premises, a conditional and the antecedent of that conditional will be true, it's going to get you that Q is true too. Now, garbage in, garbage out applies, of course, right? If these are false, maybe they'll get you something true, maybe they'll get you something false. You don't know. But if they're true, you're guaranteed that that's true too. That's a valid inference. This valid inference we call Modus Ponens. It is the most basic inference we're going to make. If P then Q, P therefore Q. Modus Ponens, Latin, the way of, I took some Latin, I looked this up. Ponens is like a participle of to put. The way of putting. But medieval logicians used it for to posit. So, you got a conditional, you posit the antecedent, it gets you the consequent, right? The way of positing. Now let's look over here. Oh, wait. I don't want up. I want Q. Here we go. let's look over here and see what happens there. If I've got a theory, say, if my theory is true, then I expect to see this prediction, right? I expect to see this observation. And then the observation comes true. That's affirming the consequent. Now look, this was an opportunity to disprove your theory. Because actually, not Q will get you not P from your conditional. That's Modus Tollens. We'll get there. But this doesn't get us T, right? If you've got a theory and that theory yields a prediction and the prediction comes true, hey, your theory hasn't been disproved. But that's not the same as proof, right? That's very, very far from proof. But hey, it's not nothing, right? You know, it was a chance to be disproved, and it wasn't. If you do this over and over again, the right amount of ways, the right amount of times, I mean, there's no right amount of times. You do this over and over again, you get more and more reasons to believe T, but it's never proof, right? It's always evidence, right? Stronger evidence, the more rigorously and the more repetitively you can do this. Stronger evidence, that's good, but never proof. Never reaches proof. So proof happens in geometry. Proof happens deductively, and deductive reasoning is largely abstracted out from reality, right? We're dealing with the P's and the Q's and the connection between things that may or may not be true. Evidence does interact with the physical world more, but it never really gets to the degree of proof, right? We get stronger evidence, but there's a gap, like, say, 1,000 is a big number, right? Infinite is even bigger. 1 billion is a huge number. Infinite, I mean, it's not even bigger. It's other, right? There is an infinite gap between 1 billion and infinite. Proof is like infinite. Evidence, you get more and more and more, but it never really amounts to proof. It does get to the point where it's unreasonable to not believe it anymore, but it's always provisional still. It's always subject to change. Let's look at these. What do you think we can get from this one? Again, let's assign or suppose that the premises are true. Are they true, right? Is not P true? I'm sorry, is not Q true? Q is any statements, right? So it's true, it's false, it's everything. Not P, not Q. It's true, it's false, it's everything, right? So let's assume that we're plugging in true statements here and see what it gets us, see what we can derive from it. The natural thing here that we're going to look for is, what about not P? So let's see if these premises get us not P. They will. Okay, so true conditional. Again, 1, 2, 3. Any of these lines has our conditional coming out true. Then we need the consequent to be false, right? If not Q, the consequent, is true, if not Q is true, well, that's going to happen whenever Q is false. Q is false here, Q is false here. So our second premise will be true here when Q is false. Our first premise is also true here. So look, this is the only model that has the first premise being true, the conditional being true, and the second premise being true, right? Not Q being true. Happens when Q is false. So what do we learn about P? P has to be false too. We're not going to write P as false. We're going to write not P. So if you've got a conditional and you reject or you get the denial of the consequent, then you get the negation of the antecedent. This is a valid inference. We call it Modus Tollens. The way of denial. All right. What about over here? Is this going to work? All right. Would making these premises true get us, well, the natural thing to look for would be something about Q. would it get us not Q? All right, so what happens if we make these premises true, right? If we assign truth to these and then model it down here. All right, well, not P is going to be true whenever P is false. This is take 2 because I got that wrong. And then, of course, our conditional is true in all of these conditions. So look, we've got two models of our premises being true. What do we learn about Q? What do we learn about not Q? Maybe not Q is true, maybe not Q is false, not enough information. So this is Modus Tollens, when you've got a conditional and then you've got the denial or rejection of the consequent, it gets you the denial of the antecedent. But it doesn't work over here. Having a conditional and the negation of the antecedent does not get you the negation of the consequent. And this is the fallacy of denying the antecedent. Again, a mistake we make all the time. Denying the antecedent. It's a fallacy. Don't trust it.